Hi, thanks for making it back. We're going to talk about what happens when it's not an exact root when you are simplifying your radicals. So the first thing to think about is with your normal square root, when you break down 48 and you look for your number pairs, you end up getting either two pairs of 2's or a pair of 4's, depending on how you do that. You take out pairs of numbers, and when you take them out, you multiply them, and anything that doesn't get paired up is left behind. And so with your x's, the same type of thing is going to happen here. You have 5 x's, so there's 2 pairs with 1 x left behind. I don't need an absolute value because while this is an even index, it's an odd inside the square root, so we can just leave our answer as this. So with the cube roots, we're going to use that same type of process where you still break things down, but the index on the outside is telling us how many we need in a group. So for this one, we have to circle groups of 3. So we have a group of 3 3's on the outside. Left inside the cube roots would be that excess, so in this case would be the extra 3. For your variables, you're going to try it the same way. So you have 7 a's, you're looking for groups of 3. So of the 7, you have 2 groups of 3, but there's only 1 a that's extra. So the remaining a goes inside. If you're a visual person, you can imagine drawing all of these out, circling the groups of 3, and so a squared shows that there were 2 groups of 3a's. So this would be our final answer. So the radicand now is just 3a. Those are the remaining parts that didn't get grouped up. So the next couple are going to be the exact same type of idea here. So for 18, we're back to square roots. So you can go ahead and break down 12, looking for number pairs or something that you can square root. So there's a pair of 2's and a 3 is left behind. For your c's, you are starting with 6 of them. So if you pair things up, overall you have 3 left that you can pair up and bring out. For your d's, you can pair up 2 of those and you would be left with 1 behind inside your radical. Now because your index is even, you have to check and see if you need absolute values. For your c's, you potentially do because it's an even degree here. And when you take it out, it is an even or an odd, so you need the absolute value around your c. Whereas D does not need the absolute value because it starts off as an odd number under the radical. So for number 19 here, you take the cube root, meaning you take 27, break it down, and look for groups of 3. The cubed root of 27 is 3, so that ends up being nice. For your y's, if you have 12 y's and you're grouping them in groups of 3, you would have 4 groups. For z's, you would have 2 z's, 2 groups of 3. And left behind for this one is only 1 more z. So with this, that's the general idea of these. Anything that's left behind, you would multiply together if there's more than one variable or more than one number. Anything that you bring out, you also multiply together if you're bringing out more than one pair of things. So the rest of this then is going to be your homework for tonight, starting with example 20 and going through example 38. It's just practicing all of these different groups with now groups of 3 or 4 or 5 based off of your index. Thank you for listening.